Welcome to Let's Roger That. I'm Gilles. In this episode, I'm going to make myself a grinding wheel balancing system for my 1950s-ish surface grinder. It's a Delta Rockwell. It's in decent shape. It's got some unique features, but the grinding wheel that I have is not quite balanced, so my surface finish is not as good as I'd like it to be. So follow me and let's make one of those things. Okay, so on my surface grinder, the grinding wheel, this is a 7-inch by 1/2 inch thick, and it's got a shaft size of 1 1/4 inch. And the retaining nut is removed with this tool. All right, so let's remove that. The idea for me is that I'd like to keep this and reuse it. All right, and there's the retaining ring that pushes, I'm sure it's not called that, but that's what I call it. And it pushes the grinding wheel against another retaining ring at the back. I'll call that the backing ring. In this case, there's a key in it. I'm not going to be reproducing that. Okay, so put that aside. As you'll see here, it's pretty snug fit, this the grinding wheel onto this shaft. So that's kind of nice. So I can use those nominal sizes. And here at the back, as you see, there's a backing plate. So I'm gonna keep this, and whatever I make is going to meet this diameter, so there's equal pressure pushing on the back. And I think what I'd like to do is make it so that, well, first of all, the outside diameter is going to be larger than this one, so therefore that'll give me space to put some weights around the plate, around the plate. So, and this, will fit the same way again in there. So that's the plan at this point. So with that, we need some measurements, of course. I've already measured the shaft. This is in fact 1 1/4 inches, which is great. Just slightly under it, like we're talking a thousandth or so. I've measured this thread, and of course it's the same diameter, so it's 1 1/4 inches, and the thread is 12 threads per inch. So that means it's 1 1/4 by 12 TPI. All right. So that's what we need to replicate. So let's get on to that. Okay, before we get really moving, sort of need to figure out the depth of this thing here. I measured that to be at 1 1/4. There's a it's 11/16 for the grinding wheel to sit into. There's a 3/16 gap for threading operation, and then there's a 3/8 of an inch of threads. So let's move on. First thing I'm going to do, I'm going to make a cradle for the whole balancing shaft, arbor, whatever you want to call it. And to do that, I'm going to use this 1/4 inch thick steel. It's square tubing, 4 inches by 3 inches. So that's how I'm going to start. The reason for that is because then, as it stands like this and it'll be cut, I'm going to be able to determine the available width on the inside for the retaining nut and whatnot for the balancing arbor. All right, so let's get started with that.
Okay, now I have this cradle, the basic shape of it, right? So I've measured this to be 2 5/16. So I'm not, that's the space that I have available, you know, at least. So, and it'll fit, this is more than 3.5, so it'll fit my, my grinding wheel, which is 7 inches. So the next step, before we do any more work on this, is to figure out how we're gonna make an arbor, how we're gonna make that retaining ring, which sits behind the nut that holds the grinding wheel in place. So let's measure that out. Okay, so now it's time to make one of these. And this is the current adapter ring that sits against the grinder wheel. And this is the nut. So I'll be keeping the nut. And the part that I'm going to make is this here. You know, so it's going to be approximately 5/8 of an inch thick. And this nut will actually be inset in that. Whereas now it sits against the retainer, and the thickness is going to allow for some weights to be placed around. I haven't determined exactly how many you know, spots I'm going to make around this ring for some weights, but I'll figure that out later on. So that's what I'm gonna do now. The circumference, not the circumference, but the diameter of this ring is going to be equal to the one that's on the machine, and that's 2.5 inches in diameter. So I'll do that. And then I'll have to work the features, and we'll be doing that all on the South Bend 13 lathe. So that's where we're going next. I'm going to take a 3-inch piece of round stock. This is 1018 mild steel. I love working with this stuff. And I'll turn that down to 2.5 inches. Then I'll, you know, bore, cut it off, etc. You know, put all the features, flip it around. And so, I mean, the order of operations is going to change when I figure that out. So let's go to the lathe. Okay, now it's time to start turning this down with a goal of getting to 2.5 inches diameter. And I'm going to take it over about an inch because I need about 5/8 out of that. So turning down an inch is going to allow me some room to cut her off later in the saw. So let's get to it. Zero my dial, back. I'll take off 50 thousandths to begin with, see how it works out. Nice finish. Chips are not too bad. Okay, so far enough along now, I want to take a measurement to see exactly where I'm going. So I'm going to do that, take a nominal measurement. And this doesn't have to be exact, but it needs to be 2.5 inches. Okay, so I've drilled up from 1/4 inch, and now I'm at 1 inch, and then after that I'm going to have to bore the hole with a boring bar up to 1¼ inch. Alright, I've reached the bottom. Excellent. All right, so now I've bored the inside diameter for the grinder shaft to go through, and that was 1 inch, 247 thousandths. Now I need to make the recess for that nut to go into, and that recess is going to be a diameter of 1.855 at a depth of 0.3125, which is 5/16 of an inch. So that's what has to happen next. So I'm going to make the initial pass, bring it out to the required diameter, and then I'll keep working on it until I get the proper depth. So I've gone in about just a little bit more than 1/8 of an inch, and I want to try to ring that nut just to make sure it fits right. So there we go. Fits perfectly, gives it just enough room to turn freely, but not to be loose. So that's great. So now I can keep on going. Okay, so this should be my final pass at a depth of 312 thousandths. There it is here. And the diameter is checked already. So let's go. And there we go. Tried to cut it on the bandsaw. Tried to do the cut-off tool thing. Didn't work. Bandsaw to the rescue. Lovely. That's a whole lot faster. Okay, so now I'm planning the shaft for the balancing system. And I needed the other portions roughly done so that I could determine what size shaft I needed, how wide of retainer I needed to hold the grinding wheel, and I needed to replicate as much as possible what's on the grinder. And then this front plate is actually going to follow the grinding wheel and go on the grinder. So that's why this stuff has to be interchangeable. So now that I've got that done, here are all the measurements. I'll leave that blank for you guys to look at. Okay, we are here. Right there. That's what we're going to turn. We're going to turn this shaft down to 1 inch diameter from here to here. So that's 2.1875. I've given myself an idiot mark so I don't miss the mark. So that's the first step that I'm going to do. This will come a little later. I'll leave this for rigidity for the moment, but we'll deal with this here first, and then probably do the threading, because no point going any further without that. So let's go. Okay, step one for the shaft, we're going to cut ourselves a 8-inch piece of 1 1/4 inch round stock. The reason I'm giving myself a couple inches is I'll put the 2 inches about in the chuck on the lathe, and then a live center at this end. Okay, step one is I'm going to face this off. should do it. I've gone down 210 thousandths, right? We're going to go down 250 thousandths. We'll measure now. And so I went down a full 200 thousandths at a certain feed rate. And now what I've done is I've slowed down my feed rate in order to get a slightly better finish, or a better finish period. And then I'm dividing the last 50 thousandths in 10 thousandths. That way I can get better finish right till the end. Let's use my caliper for now. When we get to the end, we'll definitely have to use a micrometer though. Okay, so we're at 1 inch and 45 thousandths. So it sort of jives with what I got. This shows to be 5 thousandths of an inch more. Should measure in a couple different spots just to be sure. And the beginning should probably be a little bit smaller, to be honest. Okay, so we're at 143 thousandths, 44 kind of thing. At the back we're at 44, so that's pretty nice actually. 43, 42 and a half. Okay, good. I'd rather have more than less, that's for sure. Okay, so I'll keep going with my 10 thousandths approach until I'm done with this. Okay, so I'm on my last 10 thousandths of an inch, and I've just taken a measurement, and I have a variance of approximately 9/10 of 1/1000 of an inch from here to the end, which is acceptable. I was hoping to get, you know, a 1/1000 of an inch tolerance, and that's not too bad. All right, so I'm going to do the last pass here, and that'll leave me as it is. It looks like about 1/1000 of an inch, and I'll be able to polish this down. So let's do that. Okay, moment of truth. Let's take some measuring. And looks like I'm about 2/1000 over. Let's see. And same thing here. It's okay. Actually, let's see what happens if I just give it a little pass with some emery cloth. We won't go too aggressive. We'll go with 220. See what happens. All right. Hardly took it down, but it feels nice, so we'll leave it at that for now. Now it's time to make a relief groove that's 1/8 of an inch wide right here. That's it. I gotta get it set up for threading.
In this episode's Wall of Shame, received a fantastic sticker from James Quick at Jim's workshop. You gotta check his channel. Makes awesome videos, and he's got the most beautiful stickers. So Jim, thanks for noticing that my wall was completely void other than mixed stickers. So now I have 2 stickers on the Wall of Shame. Go check out Jim's channel, and thank you very much for the sticker, Jim.
Okay, so this is the moment of truth, and see if I can actually do this. I think I'm just gonna do a little test run just for fun. Oh yeah, I can do this. Okay, so I've done a couple of more passes, and it used to fit. And there he goes. Fits very nicely, nice and loose, but yet tight enough. Perfect fit. Moving on. I made a mark, measured 2 3/16, made another mark. Now I'm going to turn it down from here, heading this way, just for fun. Do it until I get to 1 inch. There you go. Okay, so you just saw me take out some extra material off of this here. What I've done is I created a 10,000ths of an inch recess in the middle. So then this part alone will press against the grinding disc. So now what I've got to do is bore the 1 inch hole for this to slip onto the shaft. And then once I'm done that, I'm going to take this over to the bandsaw and cut it off. There we go. I'll board this to about 0.999 thousandths of an inch, and so fit this in. Perfect fit. Time to cut her up. Here's a little trick that I've learned. This is this 3-inch round stock. So if you don't counter lever this here clamp, it's not gonna tighten the piece evenly, and so things aren't going to work out very well for you. So 3-inch, this is a 1, 2, 3 block. So put your 1, 2, 3 block, bam, bingo. So that's a little trick for you. All right, so now I've faced this piece right here. Look at the finish.
Totally amazing. In any case, let's see what kind of tolerances we achieved with this. Okay, so this says 402 thousandths. Let's go 380 degrees. 401.5. So that 0.5. Okay, so 5/10 of 1,000. That's more than perfect. So now let's check something else. The fit. So we know that this one has the concave area here. So that goes inwards. Perfect. So I'm going to Loctite that in place, and that'll be the back retainer ring. So I'm more than happy with this. So far, so good. It's time to make the surface flat, and I'm going to go down 330 thousandths. But then you see my idiot mark here. And what I've done is I've calculated that at that depth I'm going to get a width of 1/4 of an inch. So I'm going to take the same thing out of a piece of round stock and super glue it in place on both sides. Okay, so I'm going to be at the correct depth at the last pass on this, just to flatten the ways, shall I call them, of the cradle. Then I'm going to clean this up on the sides, and once that's done, give it a little bit of filing, and then it's down to working on the round stock in order to make a 1/4 inch flat on it. All right, so I've got my cradle dialed in pretty as good as I can possibly get it. I mean, this is just the base of it, but I wanted to get a good start. So I'm trying to get it as, you know, within tight tolerance as possible. So this is a 5/10 of a thousandths indicator. And I've got everything pretty well within a thousandths, you see here, right? From one end to the next. So that's 1/1000ths tolerance, and that'll do the trick. So now what I've got to do is take a piece of round stock and carve the underside, and the idea is I'm going to sit it on top of this upside down and then glue it with some Loctite. And I'm taking 55 thousandths off what's going to be the underside of this round bar. I've already checked to make sure that it turns true on the surface plate, and I'm taking about 10 thousandths at a time with this end mill. Just taking it easy. I want to get a best surface as possible. Okay, so I've got this round stock ground down, you know, milled, and same with the cradle. And I usually like to try things out so I don't make an absolute fool of myself, but I'm going to take a chance here that this is going to work twice in a row. So I've got my red Loctite ready, and I'm going to lift this off, and I'm going to try to do this smartly. Put a few drops here and there, say about every ½ inch. Because you don't need to go nuts with this stuff, right? Now, the first time I put the cradle on, and it actually just sat in the right spot. I couldn't believe it. So, let's see what happens now. All right, there we go. Take this. She goes. It's actually going to work twice in a row. I can't believe it. All right, Here we are 40 minutes later. Went for a coffee. Okay, so there you are. That should be perfect. Da-da-da-da. And so now what I have to do is just take some measurements and see where things are at. All right, bring that down here. 4.16, all right. Four point 16. 4.16. Lovely. Turn it around. Let's try that again. 159.5, so that's 4.16 essentially. 5/10 is no problem. Same thing here. Same thing here. Excellent. So 4.16 it is. And just going to show you can do cool stuff with, you know, rough metal. It doesn't have to be like super slick.
Being creative. Remember, this is a hobby for me, so it should be fun. And I'm adding some touches in there that should look pretty cool once I'm done with this project. So here we go. Let's do some welding. So I'm in the middle of making the brass caps that are going to go on these leveling bolts here. Right there. And they're 1/4 inch deep because I've shaved down the bolts, bolt heads should say. And the so the holes are 1/4 inch deep, and the overall thickness of the head is going to be 5/16 of an inch. Before I actually glue all these parts together, a couple of things I should show you. It's important to have a single point of contact. So I'm going to use ball bearings, and I made sure that they actually fit through the threaded holes for the bolt. And what I've done here is I've drilled a dimple on the tip of the bolt. So I'm going to glue these into place like this. All right, so that's one thing. Then the next thing is that, you know, here are the caps that I just made, and you see I've shortened the head. That way I wouldn't have to make huge knobs, right? And they'll just fit in there and then get glued with Loctite as well. So nothing fancy, just a nice little addition. Well, it is time to put some of those 20 holes around that balancing wheel. So what I've decided to do is use my digital readout. You know, you can program all the holes to be done, and so far it's working. So there's no point filming all this crap because it's a pain in the butt, and it takes forever. Okay, so I've completed the project, and let me tell you, this was a lot of work. It lasted, you know, the project lasted a couple of weeks for various reasons, but here's the final product of the balancing cradle, aka Canadian Space Shuttle program, and I think it's going to work out just great. Now in this episode, I'm not going to evaluate the system and whatnot and set it all up. Just a demonstration of how I did it. Now this here, the balancing ring, as you noted, has 20 holes. They're made for M4 screws, and there's room for some ball bearings to go in there as well to put additional weight as needed. So how it's going to be used essentially is that I'm going to have a mark on the ring, a mark on the wheel. I'm going to balance it accordingly, and then take the ring and of course this nut off with the grinding wheel, put it onto the surface grinder, and align the lines, and that's hopefully going to work for me. It's not a system that clamps on here and you take it over to the surface grinder. But in any case, this was a whole lot of fun to make. So should you need to make one, this is perhaps an example that you could copy. Oh yeah, in regards to this balancing ring, there were a couple of methods that I could have used to produce and drill all these ring holes. I chose to use my digital readout, but you could also use a dividing head, and that would do the job as well, but it would be a lot longer to produce. I found that the DRO was a lot quicker. So that's why I went that way. So anyhow, I hope this is helpful to you. If you have any questions, comments, put them down in the comments section. Please like and subscribe, and see you in the next episode of Let's Roger That. Take care.